All right, welcome back to Calc 2. We are continuing going through our test review. This will be problem number 2B. Right, so let's see, we have to figure out the arc length. Yes, for f of x equals natural log of x squared minus 1 from x equals 2 to x equals 3. Okay, and again, the arc length formula, we have to deal with the fact that this is the square root of 1 plus f prime of x squared dx or dy, it doesn't really matter. But anyway, this is ds equals this. And of course, we're going to integrate this, and that's what we have to go ahead and deal with. So let's start putting the pieces into play here. So we have f of x equals ln x squared minus 1. F prime of x equals 1 over x squared minus 1. Don't forget the chain times 2x. So we have 2x over x squared minus 1. Now we got to square this whole thing because that's the whole idea here is we're going to square it. So we're going to get a 4x squared over an x squared minus 1 squared. We're going to have to add this to 1. But I'm going to write this as x minus 1 squared over x squared minus 1 squared. This is really 1, but I'm trying to set up to get a common denominator. So we're going to go ahead and we're going to FOIL this x squared minus 1 out. So we're going to end up with a 4x squared over x squared minus 1 squared x squared minus 1 squared. I'm not going to multiply out the denominator, so there's no point to doing that. So this is going to be x to the 4th minus 2x squared plus 1. We're going to add those two together. Okay, so we have 4 minus 2. We're going to get a 4 minus 2 is positive 2. So this is going to be x to the 4th plus 2x squared plus 1 all over x minus 1 squared. Now this is a perfect square trinomial, so we're going to be able to say something like this is x squared plus 1 squared over x minus 1, x squared minus 1 rather, squared. Now this is all inside of a square root, so we're going to go ahead and deal with that. So it's going to cancel off the squares, so we're just going to be able to integrate x squared plus 1 without the square root, without the square anymore, that's gone, divided by x squared minus 1. And this kind of suggests that we should be dealing with some partial fractions. Now, normally we'd have to divide. I'm going to take a little bit of a shortcut here. Instead of dividing, I'm going to say this is x squared plus 1, or x squared. Let's go ahead and rearrange that. Yes, x squared minus 1. I can't just go ahead and subtract 1 from stuff. Plus 1 plus 1. And this plus 1 is this plus 1 over here. Divided by, and I have x squared minus 1, and I have x squared minus 1. What I'm going to do is I'm just going to break this fraction right here. Okay, that's 2 broken. These pieces are going to cancel, so we're just going to get an integral of 1 plus 2 over x squared minus 1, yeah, dx. Now we can do some partial fractions. So we have 2 over x squared minus 1. And again, you may do this any way that you like to do it. If you want to deal with the cover-up method, that's fine. There's a lot of different ways that you can go ahead and sort out the partial fractions, especially one that's this easy. So there's a lot of different ways to do this. I'm just going to say multiply both sides by x squared minus 1. So we have a x plus 1 plus b x minus 1. This is equal to 2. FOIL this out. So we have a plus b. This is my x terms. And there are no x terms on the right-hand side, so we're going to equate that to 0. For my constant term, we're going to have an a minus a b equals, there's a constant term on the other side, which is 2. I'm going to go ahead and solve this by elimination. So we end up with 2a equals 2. for A is equal to 1, B is of course equal to -1. Okay, let's say it that way. Okay, so that's pretty convenient. So we end up with integral of 1 plus A was 1 over, what was my A? X minus 1 minus B x plus 1. Okay, we just have to integrate this whole business dx. So we end up with x integral of 1 plus ln of x minus 1, okay, minus ln x plus 1. We'll go ahead and evaluate this. This is going from, I think, 2 to 3. 2 to 3. I would like to put these in absolute values, but since 2 minus 1 is positive and 3 minus 1 is positive, I'm not going to worry about it. But that's what we have for that. And now we just plug in and we'll see what happens. So we have 3 plus ln 3 minus 1 ln of 2 minus, oh, sorry, yeah, minus ln 3 plus 1 is going to be 4. Okay, so this is x evaluated at 3 minus, so we'll go ahead and group these guys up together, minus 2, okay, plus 2 minus 1 is 1, so ln of 1, minus 2 plus 1, which is going to be ln of 3. Okay, this is x evaluated at 3. So now the hard part is 3 plus ln of 2 minus ln of 4 minus 2. Ln of 1 is 0. Minus a minus, we have plus ln of 3. And I think that's what we could say for that. I guess we could do one more thing and say this is 3 plus ln of 2 minus 2 ln of 2 minus 2 plus ln of 3. 3 minus 2, of course, is 1. So I've got 1 plus ln of 3 down here. And then 1 minus 2 is going to be minus 1 ln of 2. And that would be my arc length, right? So thank you for watching. Good luck on the test, everybody, and I will see you in the next video.